So we have another example. They say determine the value for constant b such that f of x is continuous everywhere. What does it mean to be continuous? Well, f of a, where some a is some value, must exist. The limit as x approaches a, whatever that value number is, of f of x must exist. And the limit as x approaches a of f of x must be equal to f of a. So we'll take note here that this is a piecewise function. The first piece is a polynomial, it's continuous everywhere. The second piece is a polynomial, it will be continuous everywhere. The only place we need to check is where they meet, which would be x equal to 3 or x approaching 3 from the left or from the right. So first thing first, I'm gonna go ahead and say let a be 3. So I understand. Now I need to figure out what is f of 3, or does it exist? Well, I can see here that this is where x equals 3, and it's f of x equals negative x plus 1. So if I replace 3 in there, I'll get negative 3 plus 1, which is negative 2. Therefore, f of 3 does exist. Now let's do the limit as x approaches 3 of f of x. In order to do this, we'll have to consider the limit as x approaches 3 from the left and the limit as x approaches 3 from the right. Well, approaching 3 from the left will be values less than 3, so that will be the top piece, which is negative x plus 1. Approaching 3 from the right would be values that are greater than 3, which is the bottom piece, which is bx minus a. Remember, whatever we get from these two limits, they have to be equal to each other, and that will give us an equation that we'll probably use to solve for b. So let's keep going. In order to evaluate the limit as x approaches 3 from the left, we'll do direct substitution. So we'll plug 3 in here, and we'll get negative 3 plus 1, which is negative 2. To evaluate the limit as x approaches 3 from the right, we'll plug in 3 for the x, and we get 3b minus 8. Now remember, the reason we're looking at the limit approaching from the left and approaching from the right is because we want the overall limit as x approaches 3. These two expressions, negative 2 and 3b minus 8, they have to be equal to each other. Therefore, we can write it like this. And then from here, we can go ahead and solve for b. And we end up with b equals 2. So if we rewrite the piecewise function, replace b with 2, then this function is continuous everywhere. And you can prove it to yourself by determining whether f of 3 exists, the limit as x approaches 3 of the function, and whether or not the limit value will equal the function value when x is 3. Alright, so hopefully this was a nice example showing how to determine a constant if we already know the function is continuous.